Hi, we're going to learn how to name compounds today. The type of compound that we're going to concentrate on is the ionic compound. So let's get started. Ionic compounds are made of metal and nonmetals. So these are the ions of metals and nonmetals. Or they can have polyatomic ions. So you're either going to have a metal at the beginning of the compound or this polyatomic ion. Ammonium is the only positive polyatomic ion that we know. And so we're either going to have a metal and then a nonmetal, or we're going to have ammonium and a nonmetal. And that nonmetal could be also a polyatomic ion. But see, ammonium is a cation, but there's no metal in it. But that would count as an ionic compound. So we're going to be on the lookout for metals, nonmetals, or ammonium with nonmetals. And that is an ionic compound. Sometimes people call them salts. All right, well, let's get some rules for naming them. First of all, let's make sure that it is an ionic compound. We're going to learn about molecular compounds in another video, but right now, just look for that metal, look for either the ammonium or the metal, and then the nonmetal. Okay, you name that cation first. It's easy. So it would be like potassium, sodium, whatever the metal is, or that polyatomic ion, ammonium. You name the anion last. So then it would be like the nonmetal or the negative polyatomic ion. Now, the ending of the anion, if it's just a nonmetal, ends in "ide." And we're going to look at this in a minute. All right, so the metal ions don't change their name. You just say their name, like sodium, potassium, calcium. Ammonium, keep it the same. Polyatomic ions just do not change their ending at all. But nonmetals like chlorine, bromine, we're going to change their ending. And let's have a look at that. All right, the anions we're going to end in "ide." So O with the 2- charge would be oxide. Okay, so if we had something like this, we would name our cation first, so sodium oxide. Okay. Sulfide. Again, let's say we had this compound. We say ammonium. We don't change a polyatomic ion or the cation, and it would be ammonium sulfide. So that ending ends in "ide." And this would be bromide, so KBr would be potassium bromide, and F- would be fluoride, so that would be sodium fluoride. Okay, so the anions name end in "ide, but don't mess with polyatomic ions names. Okay, let's practice naming. All right, so this first one you should all know. It's very common. This is sodium, named our cation. Chloride. Whoops. There we go. Sodium chloride. There's our "ide" ending. All right, K2S. So aren't you glad you learned your elements early in the year? Potassium sulfide. There we go. Okay. Oh my goodness. This is an ionic compound because our cation is ammonium. And we're ending in a polyatomic ion as well. And so we're going to have to review those. NO3 is nitrate. We are not going to change that ending. Polyatomic ions, we don't change their ending. Okay. All right. This is ammonium, bromide. See, it's just a nonmetal. It's not a polyatomic. It's just one non-metallic element and an "ide." This is magnesium, one element, nonmetal, and an ide, oxide. This is lithium, one nonmetal, and an ide, nitride. And this one is calcium, one nonmetal, and an ide, phosphide. There we go. Notice these are all ionic. See, metal, nonmetal, metal. The ammonium ion, that's a cation that we count as an ionic compound. Magnesium, lithium, calcium. There's the metal, and then the nonmetal. So these are all ionic compounds. Let's just keep on practicing. This would be calcium. What do you think? Sulfide. Okay. This is lithium. Oh my goodness. This is a polyatomic ion. It's more than one non-metallic atom. It's a polyatomic ion. We're going to have to recognize them and remember them. So if you want to get out your sheet for now, sulfate, sulfate. This is rubidium. Again, this anion is a polyatomic ion. We can't change it to an ide. We just have to recognize it as nitrate. All right, another polyatomic ion as our nonmetal, potassium, phosphate, a polyatomic ion. This last one is not a polyatomic ion. It's just one nonmetal, and so we're going to give it that ide ending. So I think the key is recognizing the polyatomic ions. So when you see SO4, say, woo, sulfate, nitrate, phosphate. Okay, recognizing them. All right, here we go. Now, so far we haven't had any transition metals in these ionic compounds. These transition metals can have many different charges. So we're going to name the metal, so you name the transition metal, but we're going to have to be specific about what its charge is. And so we're going to put its charge in parentheses as Roman numerals. And so, and then the nonmetal portion is the same. So something like this, okay, is going to be named iron 2 chloride. This Roman numeral is the charge on the metal. So that iron has a +2 charge. Now we have to figure out, how did we know that it was a +2 charge? Okay, so what we have to do is, in ionic compounds, we want the positives and the negatives to be equal. We want to have a neutral ionic compound. So we know that sulfate, from memory, has a -2 charge. So to make this neutral, that iron has to have a +2 charge. So iron, that's the charge on the transition metal, to sulfate. Now, here we have 3 sulfates. Each one has a -2 charge. So the entire negative charge on this compound is -6. So those 2 irons have to have a +6 charge. So there's 2 irons, they have to have a +6 charge, and so each iron is going to be +3. So this is iron 3 sulfate. All right, oxygen has a -2 charge. This copper, there's 1 copper that has to balance out that -2 charge. It must have a +2 charge. When we're naming it, it's going to be copper 2 oxide. All right, zinc always has a +2 charge. So that's really nice. It's a transition metal, but the only ion that it forms is +2. And so we just say zinc acetate. We don't need the 2 in there. That's nice. Here we have gold. All right, again, oxygen is -2, and we have 3 of them. And so this whole negative charge is -6. So what must the total positive charge be? A +6. So each gold would have a +3 charge. So gold 3 oxide. We're really going to practice this in class. Notice again, what I want you to know for sure is this Roman numeral is the positive charge on our transition metal. The last thing is we only have to use these Roman numerals for transition metals. So we're going to look at a compound. We're going to make sure, do we have a metal and a non-metal? Is it ionic? Okay, we're going to use ionic rules for naming. Then I think you should look out for a transition metal. If you have a transition metal, you're going to need these Roman numerals. We're going to practice in class. Have a good night.